Hello students, how are you all? Today's topic is force and pressure. First we will discuss what is called force, then we will discuss what is called pressure. After that we will see some numericals on force and pressure. So let us start with force. See, the idea of force is very simple. Like, say, I have got this book. Can you see this book? If I want to displace the book from this position to this position, fine. What I have to do? I have to push it. See, I am pushing it. Fine. Now again I want to get the book in the same place. Like this. I have to pull. So I am pulling it. Got it? So first I pushed, then I am pulling. Fine. This pushing and pulling is called force. Got it? Say you want to open the door of your room. So you have to pull it. Or if I ask you to close the door, what you will do? You will push it. That means by pulling and by pushing, I am applying the force on that particular object. Got it? So what is called force? The pushing and pulling on an object. Okay. That means force you are applying. Understood? Very simple. If I want to give you another idea, say this is your study table and I am saying you, just you have to push your study table so that it will change its place. So you are pushing. Again I am saying you, just get it back. So by pulling, you are getting it back. So by pushing and by pulling, we are changing the position of your study table. That means you are applying force on your study table. Understood? So that is force. Now we will discuss about pressure. Now say a very easy example I will explain with. Like say I want to apply force on this board. On this whiteboard I am applying force. See, I am applying force on this board. Fine. Now if I say you that you have to apply force only on this area. Only on this area. 1 centimeter, 1 centimeter. Okay? It's a square. You can see the shape of this. It's a square. What is the side of this square? 1 centimeter is the side of this square. That's why 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. Now you have to apply force on this. Fine. How much force you are applying here? That is called pressure. Why this is called pressure? Because you are applying the force on an unit area. Yes, that's why I have taken 1. 1 means unit. Unit area. Or we can also say that I am taking another bigger square. This is 1 meter, 1 meter, 1 meter, 1 meter. Now you are applying force. You are applying force on this area. Another unit area. 1, 1, 1, 1. Since it is 1, so that's why unit. So unit area, whether it's centimeter or meter, no problem, but 1 has to be the value. Okay? So when you are applying the force on unit area, then we'll call it pressure. Understood? So it's the definition of pressure is very simple. Like we will say that the amount of force applied per unit area. Understood? Unit area. So the amount of force applied per unit area is called pressure. What we discussed force? Force is the pushing or pulling an object, means you are applying force on that object. Now what is called pressure? Pressure is the amount of force which you are applying per unit area. Okay? So from the definition of pressure, I can write that pressure equal to amount of force you are applying per unit area. So pressure equal to force by area. Understood? Now one more example for you. Say I have taken this pen. Fine. Now this is my hand, and by this pen, from this portion which is not so sharp, but this portion is sharper. If you can see this pen, it is pointed, means so sharp it is, but this portion it's not so sharp. Now I will pressure by this side. I am pressuring. This is the pressure I am applying. Okay. Now by this point I will pressure. See, which is painful? Which is more painful? Yes. When I am applying pressure by this portion, then this is more painful for me. Why? Because of this area. Less area means more pressure. Got it? And from that example, we can say that when area is less means high pressure. Got it? So pressure equal to force by area. If your area is less, then pressure is high. Understood? So for less area, when area decreases, your pressure increases. Understood? Now we will discuss about their unit. So what we discuss first? We discuss pressure and force. So we discussed force and pressure. Now what are the units of force and pressure? Unit of force is dyne. Unit of pressure is dyne per centimeter square. Got it? Now another unit of force is Newton. Another unit of pressure is Newton per meter square. Okay? These units are in CGS system. CGS system. Okay? And these are in SI system. Fine. So now you know what are the units of force and pressure in CGS system, and you also know the units of force and pressure in SI system. One more information, Newton per meter square is also called Pascal. Yes. So Newton per meter square, you don't have to write Newton per meter square. Directly you can write Pascal. Capital P, small a, Pascal. Okay? Now let us go for some numerical based on force and pressure. For that, can you see this book? It's a thick book. Now I want to see that by which way I have to place this book on the table so that it exerts maximum pressure or minimum pressure. I mean, you will place the book this way on the table, or this way on the table, or this way on the table, so that the books exerts maximum pressure or minimum pressure. For that, we have to measure the length, breadth and height of this book. So this is the book. So I am marking the length, breadth and height. Say this is my length. See, this is my length and this is the breadth. Say this is B. Okay, can you see? Length, breadth. Which is the height? Yes, this is the height. So let us mark it here. So this is my height. Fine. So height, length and breadth. Say my length is, say, 30 centimeter. Fine. Length is 30 centimeter. What is the breadth of the book? say 15 centimeter. 15 centimeter is the breadth. What is the height? Say height is 5 centimeter. Fine. So length, breadth and height are there. From this we have to calculate how much pressure it exerts on the table when you are applying the book this way, or you are keeping your book this way, or you are keeping your book this way. Let's see. Length of the book 30 centimeter. What is the breadth? 15 centimeter. What is the height of the book? 5 centimeter. Understood? Now, say this is the table. Fine. Now, if I keep your book this way, fine, then which portion of this book is in touch with the table? Which portion? Only this portion. Only this portion is in touch with the table. And what are the sides which are in touch? Breadth and height. Length is not in touch. Only breadth and height. Fine. So when you are keeping your book this way, I mean when you are keeping your book this way, say this is my book. So when I am keeping my book this way, then the breadth, that is 15 centimeter, and this is height is 5 centimeter is in touch. Got it? Now if you are keeping your book this way, fine, then which portions are in touch? Its length and its height are in touch. Breadth is not in touch. So when you are keeping your book this way, see, I am drawing it. In this way, then which portions are in touch with the table? The length and the height. Got it? But if you are keeping your book the way you keep on your table, like this way, then which portions are in touch? The length and the breadth are in touch. Got it? So when you are keeping your book this way, this is your book. This way, then which portions are in touch? Its length and breadth. Fine. Now we will find the area of the portion which is in touch with your table. What is the area which is touch in the table? That is this and this. So what is the area? Area equal to this into this. 15 into 5. 75 centimeter square. Got it? Now, when you are keeping your book this way, I mean, see, this way, then length and this height. So length and height. What is its length? 30. What is its height? 5. So 30 into 5, that is area equal to 150 centimeter square. Fine. And when you are keeping your book this way, then its length and breadth are in touch. What is the length and breadth? Length is 30, breadth is 15. So 30 into 15, 450 centimeter square. So its area equal to 450 centimeter square. Its area. Understood? Now we have to see, when you are placing this way and this way, what is the pressure exerted by this book? We know that pressure equal to force by area. Your pressure equal to force by area. Fine. This is my first condition, second condition and third condition. For all this condition, we will take out the pressure. Pressure equal to force by area. What is this force? Force means weight of the book. Yes. So force is weight of that book which you have taken. Now, so force means weight by area. Weight means mass into gravity. Weight means mass into gravity by area. If I say you that the mass of that book is, mass of this book, the book which I have taken, mass of this book is say 5 kg. Got it? So mass of the book is 5 kg. Into gravity is, the value of gravity is 10 meter per second square. So I am taking 10 meter per second square by area. So for the first case I am finding what is the area? 75 by 75 centimeter square. Understood? Now 5 10 50. 50. This, what is the unit of weight? I told you unit of weight or unit of force is Newton. So 50 Newton by 75 centimeter square. Understood? So if you cancel it, like by 25 2 ja, 25 3 ja. So 2 by 3. 2 by 3 is 0.66 something. 0.66 Newton per centimeter square. This is the pressure exerted by this book when you are placing the book like this way. Understood? Now we will see what is the pressure exerted by this condition. Again we will put the formula: pressure equal to force by area. Pressure equal to force by area. Force means, I told you, weight of the book. Weight, what is the weight of the book? Mass into gravity. Mass of the book is 5 kg. We have taken 5 kg into gravity is 10 meter per second square by area. What is the area here? Second case we have taken out 150 centimeter square. Now this is in kg, this is in meter square. So unit is 50 Newton. Got it? By 150 centimeter square. So 1 by 3, that is 0.33, something like that. 0.33 Newton per centimeter square. This is the pressure exerted by this book when you are keeping the book this way. Understood? When I am keeping the book this term. Got it? So what is the pressure we got? Pressure equal to 0.33 Newton per centimeter square. Now let us find the pressure exerted by the same book when you are placing this way. I mean this way you are. Condition number 3. Pressure equal to force by area. Force means weight of the book by area. Weight means mass into gravity. What is the mass of the book? 5 kg. 5 kg into gravity is 10 meter per second square. 10 meter per second square by area. What is the area here? 450 centimeter square. 5 into 10, 50. This is kg, meter per second square. Means Newton by 450 centimeter square. Got it? So 5, 9. So we are getting 1 by 9 Newton per centimeter square. 1 by 9 means 0.11. It will continue like 0.11 Newton per centimeter square. So what is the pressure here? Pressure equal to 0.11 Newton per centimeter square. So we have taken out the pressure exerted by the same book when they are placed in different way. Like first we have seen when I am placing the book this way, then I am saying place the book this way, and then I am placing the book this way. Fine. So in which case you are getting maximum pressure? See, we are getting maximum pressure here, 0.66 maximum pressure. Why? Because area is less. See, pressure 0.66, area is 75. So here in this case, in the first case, the lowest area is in touch. Okay, the area is lowest, the smallest area means highest pressure. Okay, where you are having least pressure, the least pressure is in third case because area is maximum 450. And when you are decreasing the area, pressure will increase, and when you are increasing the area, pressure will decrease. Got it? So in this way we can take out the solution of the lowest and the highest pressure exerted by the same object. Understood? Thank you.